working. We're going to start kind of at the back and then work toward the front. So here we go. For this question number 16, these two formulas that you need are right here. They're at the top of your reference sheet, so you'll have them on the test. And then here for this question, we have to start with the slope. So the slope is the R value, which is 0.994, times standard deviation of y divided by standard deviation of x. So the standard deviation of y is 3.3, and the standard deviation of x is 8.5. So I am going to say 0.994 times 3.3 divided by 8.5. And my slope is 0.386. Then I'm going to use that slope and x bar and y bar, and I'm going to substitute it in to find a. So y bar is 91.5 equals a plus 0.386 times x bar, which is 51. So 91, bless you, minus 0.386 times 51 is equal to a. 91.5 minus 0.386 times 51. And a would be 71.814. So the equation would be predicted Sarah's height equals 71.814 plus 0.386 times her age, where her age is, of course, in months and her height is in inches. So that's 71 plus whatever, that's pretty tall. Okay, what percentage of the variation in Sarah's height can be accounted for by this regression? So whenever they talk about variation, they're talking about r squared. So since r is equal to 0.994, then r squared is 0.994 quantity squared. So it's 98.8% of the variation in height can be accounted for. Height can be accounted for by the LSR model. So what percent cannot be accounted for? So if they asked you what percent cannot be accounted for, you would say 1 minus or 100% minus 98.8. So 1.2% cannot be accounted for. So that is just another spin they could put on it by asking what cannot be. Okay, and then that was it in this direction. So what about this? Did you get this one?
Yes.
Okay, so I'm going to do this one real quick. The slope of the regression line is here. So for each increase in 1,000 wildebeests, the percent of grass burned is predicted to predicted to decrease, because it's negative, by 0.05762. All right.
Wait, wasn't it the amount of grass burned being the relation to the wildebeest population?
The wildebeest population is the X. And then the grass burned is the Y. And I know that because it tells me that this is slope, and slope is always your X value. Yeah. So, and they always do y versus x. It's always y versus x, not x versus y. They typically say y versus x.
That's weird. I wrote the equation right, but I don't. I'm just not seeing how the wildebeest causes grass to be burned.
The wildebeest, it sounds like, prevents it because it's a negative relationship, right? Yes. All right, so explain what this quantity measures. So it's the typical error. So when using the LSR model to predict percent of grass area burned, we can expect our predictions to differ from the actual amount by 15.9880%. And then last, based on the data, oh, we're on part C of a question. It would have helped if we would have done A and B. Based on the data, can we conclude the number of wildebeest is responsible for the decline? No. Random assignment of treatment.
Are you doing just one-on-one with him?
Hold on, I'm recording. Okay, so here we go. So random assignment of treatment was not imposed. Therefore, we cannot conclude cause and effect. All right, so now let me go backwards. I'm going to regret if these were reversed. I'm going to be like, oh my gosh. Okay, so here we are on this question. Long-term records from the Serengeti National Park in Tanzania show an interesting ecological relationship. When wildebeest are definitely X and percent burned is Y, so we're okay. So when wildebeest are more abundant, they graze grass more heavily, so there are fewer fires and more trees grow. Lions feed more successfully when there are more trees, so lion population increases. Researchers collected data in one part of the cycle, wildebeest abundance in thousands, and the percent of grass area burned in the same year. So the more wildebeest there are, the less grass area burns. That is true. Okay, describe the scatter plot. So ready? DOFS in context. So what direction does it have?
It is a moderate negative linear direction.
There is a moderately strong negative linear relationship between number of wildebeest, thousands, and percent of area burned. Do you notice outliers? I'd say with no outliers.
I did.
You did?
All right, suppose another data point, 1,080, that is a million wildebeest and 80% grass burned were added to the plot. What effect, if any, will this new data point have on the correlation between these two variables? All right, so 1,080 would be a point up here. Is he going to, and right now, this is approaching a negative value. So it is approaching -1. It's of course not there. It's probably like a -0.7, but it's approaching -1. What will that blue X point do?
bring the
R value
R value
closer to,
closer to 0.
exactly. So it'll weaken the R value. It will weaken the R value, moving it closer to 0 from its current negative value, right? So we can tell it's a negative R. It's probably like a negative 0.7. That blue X would weaken that. All right, so now we are going backwards to multiple choice. All right, so here we go. I've already done 1, 2, and 3. We did those in 5th period, so we're going to talk about those. So Japanese cherry trees tend to blossom early in spring and warm. So let me go ahead and get rid of it so we can just talk about it over again. Okay, so the idea is when the temperature is low temperature, high temperature. And then this is the month of April. And of course, this is going from April 1, not April 0. There's no such thing. But down here would be April 1 all the way to April 30. Okay? And this is maybe a temperature that's low, like 50, and then maybe this is a temperature like 80. I don't know what it is, but that's just the idea. So they have noticed that they blossom early when the weather is warm. So when the weather is warm, like it's a high temperature, they're going to blossom maybe in the first week. And then when the temperature is cool, they blossom later. So maybe they blossom at the end of April. So this would come up with a negative relationship. So there's a negative linear relationship. The higher the temperature, the earlier in April they bloom. So according to the March temperature, March would be your explanatory. We can expect a strong negative association. So the time they bloom is the response. The temperature in March is your explanatory. The temperature in March explains when they are going to bloom. If they bloom late, that's because March was cold. If they bloom early in April, that's because March was really warm. Okay, so a study of king penguins looked for this relationship. If a bird were to dive 200 meters, what is the predicted value for the duration of the dive? So we're just going to take this and we're going to substitute in 200 right here. So we have y equals 2.69 plus 0.0138 times 200. 2.69 plus 0.0138 times 200. And that answer is 5.45. So that answer is A. So using the same study from number 2, a bird dived 300 meters for 7.13 minutes. So 300 is the X, 7.13 is the Y, and this is the actual. We need to find the residual. So to find the residual, we have to remember it's actual minus predicted. So I need our predicted. So I'm going to take this same equation and I'm going to substitute in 300. So 300 comma, when I plug in 300, I get 6.83. So actual 7.13 minus predicted, which is 6.83, and that answer is B, 0.3. All right, number 4. Using the same regression from number 2, which of the following is not necessarily true? For each meter dived, the predicted duration of dive increases by 0.0138. That sounds kind of true to me. That's interpreting slope. A dive of 0 meters will leave a prediction time of 2.69. Well, that's true. If you plug in 0, you'll get that. The correlation between the dive duration and the depth of the dive is 1. Did they ever tell us the correlation was 1? Then that's probably the right answer, but let me look at the rest. Because it's the wrong answer, so it's the right answer, because they want to know which one is not true. The correlation between dive and depth is positive. Well, since my slope is positive, the R has to be positive. And if the dive depth is 175, the dive duration is 5.105. So if I did 2.69 plus 0.0138 times 5.105, and I got 2.76. Ooh, I didn't get that. Okay, sorry, hold on. 2.69 plus 0.0138 times 175. I got 5. Oh, I did get that. We're good. So the answer is C. I was just plugging something in wrong. All right, the correlation between the age of cars and their mileage, R equals 0.906. This value is based on the age being measured in years and the mileage in 1 mile. If we were changing the age to months, and the correlation would be unchanged. Changing units does not change R, right? Switching X and Y, does it change R? No. Nope. Okay, the correlation between age of cars and their mileage is R equals 0.906. This means that there is no relation. When the cars increase, the mileage decreases. When the age increases, the mileage increases. When the age of the cars go up by 1 year, the mileage goes up by 9,060. We made a mistake. It is positive. So when the age increases, the R value is positive. So it's saying when the age increases, the mileage increases. All but one of the statements has an error. Which statement could be correct? So, can we correlate a position and height? No. This is categorical. So that definitely has an error. The correlation between the amount of sun and fruit yield is R equals 0.406. I think that could be okay. We found a correlation between studying and test scores that is R equals 1.25. That's wrong. Why?
Because
R has to be between.
oh yeah, that has to be 1 and -1.
Yeah, so that's too high. A was wrong. The correlation between gender and height, isn't gender categorical? Okay, so that's not possible. And then we found the correlation between distance traveled and time spent driving is R is 60 miles per hour. Does R have units?
Nope.
The answer is no. So the answer is B, because R does not have units. So that's what's wrong with each of those. All right, determine whether each statement is true or false. Correlation requires clearly identified explanatory and response.
Yes.
False. You can switch X and Y, correlation will not change. So switch X and Y, correlation unchanged. Regression requires clearly identified explanatory and response. Yes. For me to write an equation, I have to know explanatory and response. That is true. Scatter plots require that both variables are quantitative. True. It has to be a number versus a number. Every least squared regression line passes through x bar and y bar. True. Correlation changes as units of the variable change. False. Good job. The least squared regression line minimizes the distances between the actual response variable and the predicted. Least squares. It minimizes the squared distances. So I'm going to say that's false. Switching the explanatory and response will not change the regression, the least squared regression line.
No.
That is false. It will change it. That depends. X and Y depends, or is important when you're writing an equation. The slope of the line is very sensitive to outliers with large residuals.
Yes.
Yes. A value of r squared close to 1 does not guarantee the relationship is linear. That's true. We have to see a scatter plot. A value of r squared close to 1 shows that the explanatory variable is the cause of the response variable. No, it cannot prove cause and effect. So that is false. Okay, you must have randomly assigned treatment. All right. Not many left, right? What do we have left? Oh, a whole page. Okay, so here we go. Which of the following is correct? So scientists examined the activity level of fish at 7 different temperatures. Fish activity was rated on a scale of 0 as no to 100 as maximal. The temperature was measured in degrees Celsius. A computer regression output follows. Now remember, we never ever use this. We're not going to use this until chapter 12. So you don't need to look at that. This is your y-intercept. This is your slope. This is the standard deviation of the residuals. And this is your r squared, or coefficient of determination. Which of the following is correct? Okay, so if the temperature increases by 1 degree Celsius, then the activity of the fish is expected to drop by 3.21667. It is negative, so I think that is true. I'm going to look at that. I think that's true. If the fish activity increases by 1, no, it's the temperature that's increasing, not the fish activity. So this is a no. If the temperature increases by 1, then the activity rises. No, it doesn't rise. It's negative. It decreases. If the fish activity increases, it's temperature that's increasing. The predicted, no, wrong. So the answer is definitely A. But I don't just pick one and stop. I go through them all and double check myself. That's just my test taking. Which is false? The least squared regression model would make a prediction of an activity level at 4.785 higher than the actual level of 27. That's not guaranteed. That's a possibility, but not guaranteed. Okay, the correlation is 0.9539. No, it's not, because it's negative. Ooh. Okay, so this one I don't love. This one I know is false because the correlation is negative. So we have a little problem because I don't love that first one either, but that is the standard deviation of the residuals. A temperature of 0, the predicted level is 148. That's true. The least squared regression model accounts for 91%. That is true. And for a temperature of 47 degrees, the activity level is that. Well, I just have to plug it in. Negative 3.21667 times 47 plus 148.617. And my answer, I agree. Okay, so I don't love A, but I know B is definitely wrong, so I'm going with B because the correlation is negative. All right, a study of fuel consumption of cars at various speeds was conducted. The data was plotted and a regression line was calculated. The residual plot is shown. What do you notice about this plot?
It has an obvious curve.
Yep. Therefore?
It is not reliable.
Yep, it's not a linear. It is not a linear relationship. If it was linear, it would have a random scatter. So it's telling you a linear model is not appropriate. So this cannot be linear data. Number 12, a z-score of negative 1.2. So to calculate it, you would calculate it just like you have before. You would take the mean, 1045.7 minus 1.2 times the standard deviation, which is 221.9. 1045.7 minus 1.2 times 221.9. And my answer is 779.42. So B. Okay, so that was like last chapter. Yes? Okay. The distribution of diameters of a particular variety of oranges is approximately normal with a standard deviation of 0.3. How does the diameter of an orange at the 67th percentile compare with the mean? Well, the 67th percentile is above the mean. We know that. So I'm going to find the z-score. I'm going to find the z-score, and then I'm going to multiply it by the standard deviation. So inverse norm, my area is 0.67, my mu is 0, my sigma is 1. Second vars, inverse norm, 0.67, 0 and 1. So that gives me a z-score of 0.4399. If I multiply that by the standard deviation, that gives me 0.132. So it's 0.132 inches above the mean. So that answer is C. So just using its z-score, because remember your z-score tells you if you're above or below, and it tells you what part of a standard deviation. So, I love this question. The table below shows the sample size mean and median for two samples of measurements. What is the mean for the combined 47? So this is a weighted average. This came up so much so far. So a weighted average would be take this mean and multiply it by the number, which is here. Then you take this mean and multiply it by the number of entries that have that. You add it and divide by the total. The answer is C. Now, using the information from problem 14, what is the median of the combined samples? It cannot be determined. Because I do not know. I know the 21 here. So the reason I don't know this is I know these 21 have a median of 45. And then these 26 have a median of 48. When I mesh them together, I don't know what's in there in the middle that is going to end up being the 24th data point. Because I don't know how they're going to integrate together. I don't know every single data point, so that answer is E. So I think we're done, right?
Yep.
Good job. Okay.